In this lecture, we are moving on to this much topics: moment of inertia, units of moment of inertia, radius of gyration, modulus of the section, moment of inertia. Mi is the short form of moment of inertia. Mi of plane sections by Routh rule. Mi by the method of integration. Mi of a rectangular section, perpendicular axis theorem. Mi of a circular section. Mi of a hollow rectangular and circular section. So these are the topics which we are going to discuss today. First of all, we will see what is this moment of inertia. So we have already discussed about the center of gravity and the moment. Moment also we have discussed. Okay, moment means force into the perpendicular distance from the line of action of the force to the point about which we are taking the moment. Okay, so it is the first moment of a force. We can say the moment of a force as the first moment of a force. Okay, it can be otherwise known as the first moment of a force. Now there is a second moment for a force. That is known as moment of inertia actually. Okay, what is the second moment? It is the product of first moment of the force into the perpendicular distance between the line of action and the point about which we are taking the moment. So this is known as the second moment of the force. Actually, the second moment of force is otherwise known as moment of inertia. So we can say that the moment of inertia is nothing but the force into two times, that is perpendicular distance is multiplied two times with it. Okay, force into x or force into y. Okay, that is known as moment of inertia, force into x square or force into y square. So the second moment of a force is otherwise called the moment of a force or moment of inertia. It is otherwise briefly written as mi. Sometimes instead of force we can take area or mass. I have discussed when we were having the center of gravity and all. For a plain lamina we can take area. For other cases we can take forces. Some cases we can take mass, density also we can take. So instead of force we can take area, mass, etc. But we have to square the distance along with this. Whether it is force, area or mass, we have to square the distance. Okay, so it is generally known as moment of inertia. So we'll see more about it. For a plane area, how can we find the moment of inertia? Actually, why we are finding this moment of inertia is, moment of inertia is actually representing the strength of the particular body. Okay, how much force it can bear, how much strength it can have. Okay, that value will get from this moment of inertia. So it is actually a representation of the strength of a body. Okay, so we are finding this for our what is that, building beams, uh, pillars and all. We will find this mi calculations will be done. Okay, so for a plane area, how can we calculate the moment of inertia? First, what we will do is we will divide the area into small sections. Okay, a plane area is there. We will divide the area into a number of small sections having area a1, a2, a3, etc. And the perpendicular distance from the axis, reference axis to the particular point is r1, r2, r3, etc. Let it be. Okay, then the moment of inertia of the particular area will be the sum of the moment of inertia of all the sections. Okay, for a single section or for a single element, the moment of inertia is area into square of this distance, a1 into r1 square. For the second section, it is a2 into r2 square. For the third one, it is a3 into r3 square. So for the entire area, it will be equal to, we can represent it by I. Okay, the letter I represents moment of inertia, otherwise we can write it as mi. So I is equal to the sum of all the moment of inertia, that is a1 r1 square plus a2 r2 square plus a3 r. We can write it as sigma ar square. Sigma ar square, sum of all the moment of inertia of individual elements. Now the units of this, what may be the units? Actually it is area into distance square. So it depends on two quantities. The unit depends on two quantities. One is the unit of the area and the unit of the distance. Okay, if the unit of area is in meter square and the unit of distance is in meter, then moment of inertia will be, the unit of moment of inertia will be meter raised to 4. Okay, if area is in millimeter square and length is in millimeter, then the expression have a unit of millimeter raised to 4. Okay, so this is about the unit. Now there are two terms which we have to study while we are discussing about this moment of inertia. One is radius of gyration and the other one is section modulus. So there are two terms which we have to study while we are moving on to this moment of inertia. So a radius of gyration, what is that? Radius of gyration is nothing but it is a distance from the axis of reference where the whole mass of the body is assumed to be concentrated to the maximum point or to the maximum point. Okay, it is defined as the distance from the axis of reference where the whole mass of a body is assumed to be concentrated. It is actually, I can explain it with the help of a figure later. Okay, so if the entire mass of a given body be assumed to be concentrated at a certain point, let it be at a distance k from the given axis such that mk square is equal to I. That is, if the moment of inertia is equal to mk square, okay, then that k is known as the radius of gyration. Okay, that k is known as the radius of gyration. That distance is known as the radius of gyration. It can be written as root of I by m. Okay. So it can be either kxx or kyy because we can take moment of inertia along xx axis, along yy axis, even along zz axis also we can take. Okay. So when we are taking kxx, the radius of gyration is about xx axis. When we are taking kyy, the radius of gyration is about yy axis. So we will see all these things while doing problems. Okay, no need of worrying about the discussions and all. And these are some radius of gyrations for particular geometrical structures. For a circular ring, it is equal to r. Okay, because its moment of inertia is equal to Izz is equal to mr square. Okay, mass into distance square. Distance means it is the radius. Okay, mr square. So here mr square is equal to, we can equate it with mk square. So k is equal to r. In case of a circular lamina, it is mr square by 2. The moment of inertia is equal to mr square by 2. So we will see the derivations of this and all later. Okay. So now I have given the expression only. I is equal to mr square by 2. This is the moment of inertia of a circular lamina. Here, if you are equating it with mk square, the k value will be 0.5 r square. So the k value, radius of gyration, is 0.5 r square. And radius of gyration of a solid sphere is found out from its moment of inertia. Moment of inertia is equal to 0.4 mr square. So you'll get k as 0.4 r square. So this is just derivations, just examples for finding the radius of gyration. Okay, no need of worrying about this. This is just examples. Now the second term to be noted is modulus of a section. It is nothing but it is the ratio of second moment of area and the distance from the neutral axis to the extreme fiber. Okay, earlier we have discussed about a distance. This is not that distance. Okay, this is the distance about which we are distance from the point about which we are taking the moment of inertia to the extreme end of the fiber. Okay, for example, you are considering an unsymmetrical figure. Okay, an unsymmetrical figure you are considering, and you have found out the moment of inertia of the figure by using some methods. Okay, now you have an axis about which the moment of inertia you have found out. Okay, a moment of inertia is passing through some axis. Now the distance from this axis to the extreme end of the fiber, to either its upward direction or downward direction or sideward direction, what is the maximum distance to its end? Okay, that distance is known as that distance is divided by the moment of inertia for finding the modulus of a section. So modulus of section is equal to moment of inertia divided by that distance from the neutral axis to the top or bottom of a fiber. So we will see these things while doing some problems. Okay, no need of worrying about that, and I'll discuss it later if you have any doubts. And for section modulus, the unit will be millimeter cube, because I have a unit of millimeter raised to 4 and Y have a unit of millimeter. So its unit comes to be millimeter cube, and it depends on the shape of the structure, shape of the body, whether it is rectangular, square, circular, etc. Now, methods for finding moment of inertia. We have two methods mainly. One is by Routh rule. Routh is a scientist who found out some ways for finding this moment of inertia. So by Routh's rule, you can find moment of inertia. Mainly, this Routh rule is used for plane area. Okay, area into distance square. That equation can be implemented by using this Routh rule. And the other one is by integration method. So either of the method you can use for finding moment of inertia. So by Routh rule, how can you find? How can you find the moment of inertia? The Routh rule states that if a body is symmetrical about a particular axis, which is mutually to two mutually perpendicular axes xx and yy and zz, I mean 3, okay. Then the moment of inertia about any one of the axes through its center of gravity will be equal to I is a into s divided by 3. This is there is a note. Okay, actually we have already discussed one equation, that is moment of inertia is equal to area into root square of the distance, area into square of the distance. We have discussed that equation. Okay, this all these equations are same only. Okay, area into area or mass. Okay, whether for lamina also we can take mass. When it is having a thickness, you can take mass, area or mass into square of the distance, square of the distance. This s represents the square of the distance only. Here you can see s, sum of the squares of two semi-major axes. If you are taking about x-axis, s is the distance, s is equal to x into y. Okay, so that distance will come. If you are taking about y-axis, then it is equal to x into z. If you are taking about z-axis, then it will be equal to x into y. Like that it will come. So this is the square of the distance into area or mass. Now, for a rectangle or a square lamina, it will be a x square divided by 3. A into the square of the distance divided by 3 by Routh rule. For a circular or elliptical lamina, it is a into square of the distance divided by 4. For spherical body, when it is a sphere, a into square of the distance divided by 5. So some denominators comes. That's it. That's the only difference. Okay, some denominators comes for different shapes. For rectangular square it is 3. For circular or elliptical it is 4. For spherical it is 5. So this is how we can find the moment of inertia by Routh rule. Okay. Now the second one is moment of inertia by integration. Integration you all know. Okay, you have studied it in your mathematics and all. When there is an irregular figure, okay, the easy way to find the area, moment of inertia, center of gravity or anything of this particular figure is we can divide it into small parts. Okay, we are dividing it into small part and finding the particular moment of inertia of a simple structure or a small element from that, and now we are integrating from one end to other for finding the total moment of inertia. That's the thing. So we are dividing the figure into a number of parts. We are finding the moment of inertia of a simple small structure or small section of that figure, and now we will integrate this equation to this end to this end. Okay, one end to the other for finding the moment of inertia. So this is the method by integration. So here in this figure, we have divided the figure into a number of strips, small strips. This green color portion is taken and that portion have an area of dA, that is the area of the strip, and x is the distance from the x reference axis, y is the distance from the x reference axis. So x and y are the comes to be the center of this particular figure, particular what is that particular element. Okay, now moment of inertia about x axis or y axis, y axis will be equal to dA into x square. Okay, area of that figure into x square, perpendicular distance. Okay, about y axis. So about x axis it will be equal to dA into y square. Okay, like that it will come. So we'll get Iyy, that is moment of inertia about y axis is dA into x square, and moment of inertia about x axis is equal to dA into y square. When it is for the entire figure, we have to take sigma, the total moment of inertia. So how can we find the total moment of inertia? That is by integration only. This total is found out by integration method. So that we will see later. Okay. Now we are moving on to the moment of inertia of different structures. Okay, different figures. We will move on to that. For a rectangular section, so you are given with a figure. having a rectangular shape. How could you find this moment of inertia? Okay, here since it is a rectangle, the x-x axis or center axis comes through this x-x, and another perpendicular axis will be y-y. Okay, it will pass through the center. We can take it like that. Okay, now the area, we are taking a strip. Okay, we are taking a small strip. Since this is a very large figure, so we have to find the moment of inertia by a particular procedure. So we are dividing it into small strips. We are taking a small strip PQ. Okay, a small strip is taken, and the area of the strip is b into dy, because its distance is dy, the thickness is dy, and its width is b. So b into dy. Now the moment of inertia of this particular section about x-x axis will be equal to area into y square. Okay, that is b dy into y square. So this will be the moment of inertia of this particular section about x-x axis. Now for finding the total moment of inertia of this section, you have to integrate this. Okay, so that's what we have discussed about moment of inertia by integration. So we are integrating, we have to integrate it with our axis comes here. So this is our origin, this is the x-x axis, and this is the y-y axis. So this point, from this point to this point, we have to integrate for finding the moment of inertia about y-y axis. From this point to this point. What is this point? This is 0 and this entire distance is d. So this point will be minus d by 2 and this point will be plus d by 2. Okay, when we are considering it as a graph or this as the origin, this will be minus d by 2 and this will be plus d by 2. So we are integrating the equation with giving the limit minus d by 2 and plus d by 2. And after integration you will get it as b d cube divided by 12. So about x-x axis it will be b d cube divided by 12, and about y-y axis it will be reverse, db cube divided by 12. So you can integrate about y-y axis, you can do that. So for x-x axis I have done that. Okay. So this is for a rectangular section. Now, so we can say that the moment of inertia about x-x axis for a rectangular section is b d cube divided by 12. This equation you have to study. And for y-y axis it is db cube, reverse, db cube divided by 12. Okay, that you have to study. Now for a hollow rectangular section. So this is a hollow rectangle. There is an outer rectangle and inside that there is another rectangle. So you have to find the moment of inertia of this figure, this hollow rectangular section we have to find. So what we have to do is, for the entire section you have to find first, for the inside rectangle you have to find then, and we have to subtract the moment of inertia of the larger rectangle from the smaller rectangle. That is the thing you have to do. Okay. So for the larger rectangle it is b d cube by 12 about x-x axis. For the smaller rectangle it is b1 d1 cube divided by 12. Okay, because its breadth is b1 and its depth is d1. Now for the hollow section, what will be the moment of inertia? We are subtracting both. Moment of inertia of outer rectangle divided by minus moment of inertia of inner rectangle. So it comes to be b d cube divided by 12 minus b1 d1 cube divided by 12. And this is about x-x axis. About y-y axis it will be reverse, db cube divided by 12 minus d1 b1 cube divided by 12. So this is the case of everything. Okay. Now, so this is very simple. Okay, only the equations you need to find, you need to study. Now we will move on to some theorems are there. Some particular theorems are there which helps to find the moment of inertia very easily. Okay, so I will introduce you one theorem. Theorem of perpendicular axis. You may have studied this in plus 2 classes and all. Anyway, so it states that if Ixx and Iyy be the moment of inertia of a plane section about two perpendicular axes meeting at O at the center. Okay. The moment of inertia Izz about the axis Zz perpendicular to the plane and passing through the intersection of xx and yy v Izz is equal to Ixx plus Iyy. It is very simple, nothing. There are three axes. Okay, for a three-dimensional figure, there are three axes: xx, yy, and zz. Okay, x and y are on the same plane. Okay, x is in one direction and y is perpendicular to that. Here you can see in the same plane, this is x and this is y. They are perpendicular to each other. Since this figure is slightly curved, you may see it like this. Okay, so this is perpendicular to each other, x and y. Now there is another axis, z is there. Okay, three axes are there. So in some cases you have to find the moment of inertia about all the three axes, x, y and z you have to find out. Okay. Now they are telling us that if you got x and y, moment of inertia at x and moment of inertia at y, then it is very easy to find z, because z will be equal to ix plus iy, ixx plus iyy. So this is known as perpendicular axis theorem. Okay, so this is very simple. And regarding in the case of a circle, it is like this. The same principle is applied for a circle. This will be understood only after seeing the equations for circle. Okay, so that you can see later. So the perpendicular axis theorem is very simple. When you have the moment of inertia about x and y axis, then it is very easy to find the z axis moment of inertia, because iz will be equal to ix plus iy. That's it. Now the proof of that, how that came, how that equation came. Okay, the proof of that is given here. This thing is very simple. Actually, you can just go through this. Anyway, I'll tell you. If you don't understand, means you can read it. It is very simple. You are taking a lamina. This is a lamina. In that lamina, we are taking a small section P. Okay, we are taking a small section P. So this may be this is the center of the lamina. This is the z axis, this is the x axis, and this is the y axis. And this point, this small portion, a small circular portion, is at a distance of x from the y axis, y from the x axis, and r from the z axis. The perpendicular distance of this particular circle from the O point, from the axis, are r distance from z axis, y distance from x axis, and x distance from y axis. Okay. Now, from the geometry of this figure, we can say that r square is equal to x square plus y square. This is by means of Pythagoras theorem. We are considering it as a rectangle, triangle, and we can derive this formula. It is r square is equal to x square plus y square. Okay. So this is from the geometry of the figure. Now, moment of inertia of lamina P about x-axis axis will be equal to dA. Let the area of this particular small circle will be dA. Okay, let it be dA. So dA into y square. About x-axis it is y square. We know that. Okay, because I is equal to area into distance square. Similarly, about y-axis it will be dA into x square. Okay, you are sure, right? Similarly, along z-axis it will be equal to dA into r square, because r is the perpendicular distance from z-axis. Now, dA into r square. This r square can be written as x square plus y square. We have already got that. R square is equal to x square plus y square. So we are substituting it here. X square plus y square. Now dA r square is equal to dA x square plus dA y square. So what is dA x square? It is Iyy. And what is dA y square? It is Ixx. So we can say that Izz is equal to Iyy plus Ixx. So this is the proof for perpendicular axis theorem. It is very simple, and if you didn't get this now, you can read it again, and it will be very easy to understand. So there are some figures which uses that principle. So we will move on to the circular section. We have already discussed about rectangular section, hollow rectangular section. Okay, moment of inertia of a rectangular section, how it can be found out. Moment of inertia of a hollow rectangular section also we have seen. Now we will move on to circular section. How could you find the moment of inertia of a circular section? Okay, so in this case, we will again, integration method itself we can use. We will take a small strip of a circle. So this is the large circle. We will take a small strip of the circle having an area dA. Okay, that area will be equal to 2 pi x into dx, because the perimeter into the breadth. Okay, perimeter of the circle is, this is at a distance of x from the center. So 2 pi x will be the perimeter of the circle into dx. Dx is the thickness. So that will be the area of that small strip. Okay. Now moment of inertia of that circle about x axis or y axis will be area into distance square. That is 2 pi x into dx into distance. Again the distance is x. So x square. So you'll get it as 2 pi x cube into dx. Now what we have to do for finding the total moment of inertia? You have to integrate this equation. So how, from which point to which point we have to integrate? We have to integrate it from 0 to maximum distance, that is r. So we are integrating this equation from 0 to r. You will get finally it as pi by 2 r raised to 4, or you can write it as pi by 32 d raised to 4. So about z axis the moment of inertia is found out to be pi by 32 d raised to 4. Okay. Now about x and y axis, by using perpendicular axis theorem, it will be half of this z, half of whatever we got here. Okay, so that is ixx and iyy is equal to pi by 64 d raised to 4. Here ix and iy are equal because it is a circle. X and y will be equal for a circle. Since it is a circular shape and it is symmetrical about x and y axis, we can take it as same. Okay, pi by 64 d raised to 4. Now for a hollow circular section, it is very easy. You have to find the total moment of inertia. You have to find the moment of inertia of this outer inner circle. You have to subtract both. So for the outer circle it is pi by 64 d raised to 4, capital D raised to 4. For the inner circle it is pi by 64 small d raised to 4. And for the hollow section it will be subtracting both. That is pi by 64 into capital D raised to 4 minus small d raised to 4. Okay, along x axis, and along y axis also it will be same. Along z axis it will be pi by 32 d raised to 4 minus d raised to 4. And we can use this principle only when the center of both the circles are same. Both outer circle and inner circle are same. Then only we can use this principle. So this is about today's class. Thank you.